Just as the second law of thermodynamics states there must be a temperature difference for heat exchange to occur, so there must be a pressure difference for fluid flow to occur. Because of friction, as the fluid moves through a pipe, it will lose some pressure, which results in a delta P. Delta is a Greek letter that is commonly used to express differences between parameters such as delta P for pressure differences and delta T for temperature differences. In a refrigeration context, the lowest pressure in the system always occurs at the inlet to the compressor and the highest pressure at the compressor outlet. Flow will always occur from a higher pressure to a lower pressure.
One of the laws of fluid flow says that fluid will only flow from a high pressure to a low pressure. I like to solidify this with students by asking them if they've ever seen water flow up a hill. And of course, the answer is no, they've never seen that. That would be very, very strange. But the question now is, why is that? Well, it's because on top of the hill, due to gravity, we have a greater pressure potential than at the bottom of the hill. So if you're to dump a cup or a bucket out on the top of the hill, of course it's going to flow downward, and the reverse will never happen unless we have something to cause that flow, like a pump.
Since the refrigerant vapor flows from the outlet of the evaporator to the compressor, we know that the pressure at the evaporator must be higher. To help reinforce this, consider that if the compressor's suction pressure was higher than the evaporator pressure, the refrigerant would be flowing backward through the cycle.
In this example, we have an evaporator that has a pressure of 45 psig. And we're also told that at the compressor suction inlet, the pressure is 42 psig. So the difference between 45 and 42 is the pressure drop that's in the piping that connects the evaporator to the compressor. Probably don't even need to write this out, but I will for the sake of the video, that our delta P or our pressure differential is equal, our delta P equals 45 psig minus 42 psig, which equals, of course, 3 psig. Now, what is this coming from? Again, I said it, but I'll say it one more time. The pipe that connects the outlet of the evaporator to the inlet of the compressor has friction. As the refrigerant flows through the pipe, it will be slowed down a bit, and that will result in a pressure drop. I do want to point out one thing, which is that if we were to calculate this using absolute pressure, it would look like this. Our pressure differential would equal 59.7 psia minus 56.7 psia, which still equals 3, psi in this case. So it doesn't make any material difference when you're calculating a pressure drop, whether you use gauge pressure or absolute pressure, so long as you're consistent and you use the same, both gauge pressures or both absolute pressures.
Many factors contribute to pressure differences in a system. First, the diameter of the pipe. The larger the diameter, the less pressure drop there will be. Second, the length of the pipe. The longer the pipe length, the greater the pressure drop will be. Third, pipe fittings and valves. Whenever a fluid flows through a valve or around a 90, there are pressure losses as fluid changes direction. This results in a pressure drop. Finally, the velocity of fluid flow will affect the pressure drop. The faster the fluid is flowing, the greater the pressure drop will be.
So typically, if a system is properly designed, on day one, there won't be excessive pressure drop through piping. However, maybe to save money up front, a contractor or designer, or who knows, maybe even the owner will opt for smaller pipes, which will result in pressure drop issues from the very get-go. The more likely scenario, however, is that over time, a system was added to. Maybe a couple years after installation, they added another room, a few years down the road, some more equipment. But in doing that, they didn't increase the main pipe header sizes. And now we can have a pressure drop issue due to the added capacity on our system that we're forcing through the same size pipes. This is unfortunate when this is the case because you'll spend more money in energy costs as well as see a decrease in your system performance.